那我们先讨论第一个问题。第一个问题是考虑到其他编程语言的发展，大家认为 Rust 应该如何调整其发展策略，以保持其竞争力和独特性？
The first question was, considering the evolution of other programming languages, how do you think Rust should adjust its development strategy to maintain its competitiveness and uniqueness? Maybe Josh wants to.
Sure. Trying to make sure other people have a chance. Sure. So a couple of fun things. Rust has the benefit of getting to see the evolution of a lot of other programming languages in the past. So for the most part, we've gotten to avoid remaking a lot of the same mistakes other languages have made, and we get to make exciting, new, different mistakes instead. And I genuinely think that's a good thing, that we have the benefit of not having decades of legacy behind us. We have decades of legacy ahead of us to look forward to, and we are trying to plan ahead for it. But other languages are continuing to move as well. As Bart said in his talk, there's kind of a Cambrian explosion of languages enabled by a variety of factors, but especially things like LLVM as a code generation backend, so people stop worrying about that part. And I think we are benefiting as much from that, of seeing here's all the other things out there and what exciting features they have people like, and kind of we don't try to be right on the cutting edge of that, but we certainly look at what a lot of other languages are doing and saying, hey, you know, we could maybe use a stable ABI, we could maybe use a C compiler. That kind of thing looks like fun.
Do you have intuitions for what Rust's sort of mistakes, exciting new mistakes might be? Or is everything perfect so far?
We have absolutely made some fun mistakes. Off the top of my head, I would say that we have not yet found the perfect balance for how conservative the standard library should be and how much it shouldn't be. That it's important that we not adopt things so quickly that people are stuck with them forever in the standard library, but sometimes we err too far in the other direction. And for example, I think it has been more than long enough that we ideally should have an async runtime and a async set of files and networking and various things like that in the standard library. So I would say we are conservative to a fault in what we pull in. And I think that it's good that we do that because we want to last for decades, but that can make it really tough for people to know what we should pick.
So one good example is async iterator, which still not yet stable, and basically Tokyo have to have, like Tokyo already reached 1.0 with its stream or async iterator implementation. So it can be actually quite difficult for the ecosystem, because it's not in a standard library. And like, if we actually stabilize async iterator in the library, it might not be compatible with what Tokyo has for the stream.
Yeah, I feel like it's a very hard question to answer in a roundtable panel, because I feel like there's a bunch of things that make a bunch of us uneasy. We've talked about them. They look like they might be future mistakes, but nobody wants to come out, you know, in front of a room full of Rust enthusiasts and say, oh, well, here's the thing that's really garbage that we did, until we're 100% certain it's garbage. And so I think ask us again in 5 years when some of these things are far enough in the rearview mirror that we're like, boy, I wish we could go back to that decision.
Alex had a question about what do you think of Mojo language, which claims to have Python's syntax but has similar design to Rust?
Sure, like I think that is a very interesting challenge that they take on, that they want like syntactic compatibility with Python. They seem to be achieving really cool results in the optimization. I don't think that's really inherently tied to the language though, but I mean they do cool stuff, and I'm excited to see where it goes.
Likewise, I think it's really fun that they have a smooth gradient, or they're planning to have a smooth gradient from dynamic Python to fully statically typed and type inference and similar. I think the biggest open questions around Mojo are, it's an ambitious set of goals. It's currently a one company project, and that one company, you know, hopefully their other business plan that they're, you know, using to support this language they're giving away pans out, because it's not yet an exciting enough language that people will pick it up if they drop it. So adoption question mark, but it's a really exciting and ambitious idea, and frankly, you know, I think that in general, open source has the benefit of not having to say, oh, no, we should win and they should lose. No, I hope they succeed. That's a great plan. I hope they pull it off.
I mean, one thing both of these questions ask that I think might be a bit of a mispremise, I've done a lot of stuff with the X window system, as Josh has a bunch of other people, and you know, people always say, well, what do you think about the replacement for X? And we're like, well, if it works out, awesome, right? I mean, and I think the same thing with Rust. If somebody comes along with a language that, you know, is a better language, it's not like we'll all be hurt. And we're not trying to win. We're trying to find the best kind of combination of features and stuff. Okay, Josh disagrees. I'll let him talk. But there's very much a sense of, you know, sort of, the fight is against software, right? The fight isn't against people.
I would mostly agree with you, except I think I would say one of the advantages of Wayland was the people building Wayland as a replacement for X were mostly the X people who were glad to see it die. And like, it's kind of the success, it is X12, it is the successor. It's not like a competitor that was killing X. In that spirit, like, if Rust heavily evolves, I hope it's with a lot of the same people involved. I don't think that, like, the only way we get replaced involuntarily is if we utterly fail to keep up and decide, oh, no, we're stuck in our ways and somebody else is going to have to replace us for any progress to get made. We can actually go along with things.
I now completely regret having brought up X. I retract.
第二个问题呢，我是想问，就是随着硬件技术的发展，就是大家认为 Rust 编译器在未来可能会面临哪些新的挑战和机遇？比如说，就是各种，就除了 CPU， 现在还有 GPU， 有 GPU， 各种FPGA 之类的这种异构平台，就是 Rust 编译器该如何面临这些新的挑战呢？
With advancement of hardware technology, what new challenges and opportunities do you foresee for the Rust compilers in the future for targets like general purpose GPUs, FPGAs, outside the CPU architecture?
So, I think, so if we look at how GPU started, initially what you could do, so you had when CUDA started out, you could write C code, but it was a relatively limited form of C. The things you could do with memory were somewhat limited, and as the hardware evolved, it became less of a GPU and more of, oh, here you have a lot of very small CPUs that can do anything a normal CPU can do. And it's difficult. And so basically, this is why Rust now can easily run on GPUs, because it's basically just a small CPU. You have memory and everything that a normal CPU can do. I think Rust on hardware or FPGAs is probably going to follow. Well, it's not really clear how it's going to work out, but I would say that initially the things that you would be able to express in Rust that would map to hardware would be very limited, and you wouldn't be able to do a lot of things that Rust does around memory. But who knows how this will evolve in the future.
So in addition to that, As far as hardware design goes, I know that there have been efforts to involve modern languages in hardware design. The RISC-V folks, I was just informed about this yesterday, the RISC-V design folks are working heavily with a language called Chisel that is designed to use Scala to generate Verilog, give you a higher level interface to it. And I could imagine someone using Rust in much the same way. The idea of more directly translating the Rust itself to hardware is an interesting open question, but then if you asked people a decade ago, they wouldn't have said you could translate Rust directly to GPU code, and that is partly because of advancements in the hardware, but partly because maybe nobody was quite the right brand of crazy to try it. So if somebody comes up with something clever, but either way, we may well need new backends for that. We may need some new language constructs for that, but I hope we see them.
So I will have to say that Chisel is not basically translating Scala directly to hardware. So it's still like a DSL built on top of Chisel, which generates code to generate the Verilog.
There is Clash, which is actually compiling Haskell to Verilog, and I believe also the other format that you would use for VHDL. And so like this stuff does exist, and you know, like if the functional languages can do it, then we should be able to do it, right? So
I think what's more interesting probably is to like have a function of Rust code which like can be more easily mapped to Verilog, for example, and then have that function itself being compiled and then generate probably like proc macros or other compiler magic things to calling to less specific, like generate wrapper functions for calling that specific function or a block on hardware. That might be more interesting or might be more feasible than like compiling the whole Rust program to Verilog. That's my opinion.
You had something you really wanted to say.
I was just going to say, I agree. Transparent offload seems like a good first target of take this one function that's written in a subset that's easily functional and move it over here and move the data transparently. Sounds like a great starting point.
Yeah, I mean, as somebody who's helped a student build a hardware definition language as an embedded Haskell DSL, I feel like hardware has a fundamental problem. I mean, FPGA, compile to FPGA has a fundamental problem it hasn't solved yet that's bigger than Rust, which is that we don't have the equivalent of even the 1970s level of back-end technology. The actual code gen for hardware, that is going from a high-level model to actual layout of LUTs, is not really a solved problem. Doing it for Verilog and VHDL is bad enough, and most of the time we dodge it. But Verilog and VHDL look a lot more like hardware assembly languages than they do like hardware high-level languages. And until we solve that problem, I feel like, you know, that's ocean boiling for Rust. Having said that, I think, yeah, the thing that is going to happen is that TPUs are already starting to move inside CPUs. The wheel turns like it always does. And we are in a very good place, I think, to, you know, compile for massively TPU-enabled computers right now. And that's probably the near-term future. And you can do a lot of things with a TPU that, you know, wouldn't be a lot faster on an FPGA.
One missing piece that may help enable that you know, hardware design renaissance as well is we haven't seen a lot of good work translating all the way down to the FPGA LUT level, in part because it's been so ridiculously proprietary. There are a few older generation FPGAs where people have reverse engineered enough to start playing, and maybe those tools can advance, but until some major hardware vendor, whether an existing FPGA vendor or a new player, says no, 100% open source from day one, like, or from now anyway, then it's going to be hard to have that same renaissance for design if we can't play and experiment and do the weird thing.
I think the design of the Rust language also influences some hardware design language. Okay, well, we move to next question. 第三个问题啊，就是除了 NTP 啊，大家认为还有哪些传统的网络协议或者是技术适用于 Rust 进行重写或者是优化？
Oh yeah.
Apart from NTP, what kind of traditional network technology do you written or optimized in Rust? Actually, I think we've already discussed a bit.
Yeah,
talk.
yeah, but like, I don't know, like I thought of some more stuff when I went off stage, right? As that always sort of happens. I think what's really exciting is that Rust is sort of entering the, and we see that it's sort of getting quite popular or at least used by the network people. So we see this, for instance, with the sort of like the maintainers of the .NL subdomain or top level domain. They're actually starting to use Rust. They're starting to use like SIMD to like speed up certain parsing tasks, etc. And so that'll trickle down. Concretely, last week I spent some time on curl, and Nicholas has also looked at this a little bit. Like curl is actually, you can use certain Rust components in it. You can use Russells, you can use Hyper, and so that means that all of the interesting stuff in curl at that point is sort of already written in Rust. So this is sort of HTTP and HTTPS. Well, we're working on precision time as well, which is sort of technically a networking thing too. So DNS is being actively worked on, and then there's a bunch of other sort of more fundamental things that also are sort of in the works. So I think the future is very bright in networking.
In the embedded space in particular, rewriting the stacks in the bottom layer stacks for everything in Rust looks like a good idea right now. The security and performance problems in IoT space are legendary, and it's not just TCP/IP; it's Bluetooth and LoRaWAN and whatever today's the next stack is. We'd really like it to just work.
It's really, oh, sorry, go on.
I just want to say, while there is some value in rewriting an existing project in Rust, the actual end benefit is not that big. What I find more interesting is when you're developing the next generation of a particular piece of software, and as part of that, write that new generation in Rust. For example, the Crane Lift compiler backend started off as the idea that there are some fundamental flaws. It came from an LLVM developer who saw some flaws in the design of LLVM, or not flaws but inefficiencies, and thought, okay, I want to try making a compiler backend with a new design, a new, cleaner intermediate representation, cleaner data structure design. And they could have just done it in C++, just rewrite from scratch, but still in C++, but with cleaner data structures. But they decided to do it in Rust. And I feel that doing things this way is generally much more beneficial than just a simple rewrite.
I think related to that is an area where Rust gets used a great deal is cryptocurrencies. And the reason for that is that they are generally greenfield projects that need high performance, and Rust is a fantastic fit for that. And so you don't have to worry about any integrating with old C code or C++ code. And so I think, yes, if you can rewrite from scratch, it does make things a lot easier.
I think there's a lovely balance as well. Like, it's wonderful seeing the next step taken past a project that has a very long legacy of like taking something and making it library capable, or giving it a safe interface, or giving it new features that its old design couldn't support. I also just wanted to express like a huge appreciation for people who go the extra mile and build something that is 100% compatible. Like, RipGrep is wonderful, and it's also awesome that people are building things like a core utils in Rust that is 100% core utils compatible. Both of those have incredible value, and I really appreciate when a project says, well, we care about 100% compatibility, not 90% compatibility, because that last 10% can mean, oh, everybody can adopt it, there's no good reason not to.
Alex just raised a point about pseudo RS, which I think is also a good example.
Yeah, I was also going to bring up Hyper, which is an HTTP implementation, and it sort of is async from day one, and that is just not something you can really do in like a nice way in C or C++. So because Rust is a different language and it makes some different sort of fundamental choices, an implementation in Rust can already be much better than what you can sort of realistically achieve in C or has been achieved so far. I mean, also, yeah, NTPD and sudo try to, actually they often implement fewer features just because some of the features that are in the original implementations turned out to be bad ideas. And so that makes them better implementations because there's just less to go wrong and less to learn.
We move to the next question. 第四个问题是 Rust 被纳入 Linux 之后呢，就是会对 Linux 发展和生态带来哪些影响，以及对操作系统这个业内带来什么影响？然后，对这个上游的 Rust 有哪些正面的影响？
Okay, this question majorly for me, I guess. When Rust was merged into Linux kernel, what does it have for the development and ecosystem of Linux? What does it have for the operating system industry? And what does it have for the Rust language? The future of Rust language. So that's yeah.
You have 1 minute.
It's actually very hard to say because we're still kind of like just get started. Right? We still have very few abstractions being upstreamed. But I think eventually, like even though we just have very limited number of abstractions, there's already companies like Google, Microsoft, Cisco look at using the very limited things we have and develop like Android binders, file systems on top. So I think it's positive that companies are looking into using Rust to write drivers and kernel modules. And then, like, I think eventually people will, if we get enough abstractions upstream, then people will start thinking of using Rust as a first choice to write kernel module, not C. Because, I mean, why not? You get much better nice language features. It's much less likely to make mistakes. And generally, I think it will make the iteration faster, like development cycles. And I think one of the important things is actually brings fresh blood to the Linux kernel community, because like many people who started the Linux kernel development still working in the same industry. So like the general average age has been just growing over the years, right? And like without projects like Rust for Linux, well, me personally is already start doing kernel driver development before Rust for Linux, but I think there are people more in my age or like just maybe college students who will be interested in writing Linux kernel drivers when Rust is actually a serious thing. Because many people are actually frightened by how complex the kernel C thing are. And then I think we are trying to change that. Hopefully there's still one sub-question. Hopefully with the experiments that we have in Linux kernel, it can provide some useful feedback to the language design in Rust.
I'm going to jump in real fast because I have to say this. The other thing that people are really frightened about with Linux development is the Linux community, which can be a really terrifying place to work. I think one of the things Rust brings to Linux that's really underemphasized is the Rust community, which is absolutely a welcoming, friendly place that I think is going to be way more fun.
So I wanted to comment a bit on what the Rust for Linux project can bring to the Rust language a little bit, because I think this is an important part of it. And you know, in Gary's talk earlier, there's already a number of unstable features that the Rust for Linux project needs, and a lot of these I don't think get a lot of attention in the overall ecosystem because they're very specialized. And so in some sense, having extra, uses of that is good. But I actually don't think that's the biggest benefit of it. I think the biggest benefit is actually less technical and more of like having a project and a group of people that are using Rust in a more domain-specific area and trying to develop the processes to enable those kinds of applications. And it may be that, in this case, it's the kernel, but maybe the next one is FPGA or some AI platform or whatever the future is, right? Having a project that we can set up and learn how to communicate what the project can do and what the language can evolve to be to best suit different applications. And I think that's a really maybe underrated benefit of the project.
And another thing that's kind of obvious but worth saying is that having Rust in the Linux kernel is just a huge vote of confidence in Rust. Likewise with Windows. Like, you can't say Rust is a flash in the pan or it's going to go away when it's being used in this way.
It's still quite experimental in the kernel. So yeah. Well, it's like the Rust deploy is still considered experimental in the kernel. So I mean, it might be removed in its entirety at one day, but obviously that's not what we hope for. So basically, yeah, it has to be. We still have to continue to and evolve it so that like as long as there's important users in the kernel they use Rust, then probably at that point we can say it wouldn't be going away. It would be staying there.
Yeah, I wanted to say that I'm very excited about how you're pushing the APIs for allocation, because I think that there's a lot to gain in Rust still by sort of controlling allocation better. There's ideas about like custom allocators, and then it sort of got stuck, and now maybe it's moving again. But that just seems like there's so much on the table there, making that more convenient and sort of the natural choice for structuring your Rust programs.
Okay, we move to the next question. 第5个问题，除了操作系统之外，还有哪些计算机科学或者是工程领域课程可以更适合引入 Rust 作为教学语言？
Apart from operating system, what domains in computer science or engineering, what curriculums in computer science or engineering do you think would be suitable for introducing Rust as a teaching language? I guess that's a question for you.
I guess I'll start with that. I mean, I just taught a Rust web course. I think it's a great language for the web, for web development on the back end right now, and it's getting there for the front end. So there's something clear the other end of the stack. The great attraction of Rust for me as an educator is that it's the more sophisticated cousin of Python, in that it is really a general purpose language. And sure, it's especially great at systems, but there isn't really anything that it inherently is terrible at, because it's just too general to be that. And so my optimism is that there are some areas that are low-hanging fruit, there are some that are taking longer to develop, but ultimately, like I said in my talk, I think the plan is to start introducing it in everywhere we can, to the point where it really becomes, a thing that everybody can accept, and that's great for us. It's been a long time since we've had one or two languages that we can go, wow, we taught all the students those, and now they have a good start. They're in a good place.
One interesting metric that I think is worth looking at is in the very early days of Rust, and for a while afterward, like the people who were writing Rust were the ones who were like, well, I really want Rust, so I'm going to use Rust whether it's the right fit or not. And then it becomes the right fit for more and more places. And what we start seeing now is like Alice from the Bevy project mentioned that they get a remarkable number of people who show up and said, well, I want to use Bevy. There are a few areas where that's starting to be the case, and I think that there will be more and more of those over time, whether it's, I want to use this project, so therefore Rust, or I want to work in this area of computing, therefore Rust. That is going to be one of the major signs we haven't had yet, but will start to have more and more and more for Rust making it.
那我进入最后一个问题last question 随着 Rust 在中国的普及中国的大家认为中国的技术社区和企业应该如何参与和贡献 Rust 的全球的发展？
As Rust gains popularity in China, how should China's tech community and enterprises participate in and contribute to Rust's global development?
I can start with this. So one thing I would like to see more of is more collaboration on compiler development and the project itself. I know this has been very US and European focused in the past, and I think just more involvement internationally would be a good way to start with this, but also ecosystem-wide, but yeah.
Yeah, I was gonna bring up we never hear from y'all, right? And maybe that's our fault, but and I suppose we're here now and we get a bunch of local stories, but yeah, that connection is I think sort of been missing, and it's I think we can build really cool stuff together. There's clearly a lot of sort of excitement and talent and knowledge here that we can also use. So reach out, GitHub and the Zulip, etc. It's all available, and even with sort of limited language skills, you can contribute a lot.
One specific area, especially even if you aren't necessarily wanting to dive in and working on the code yet, there is support for translations of compiler error messages in progress right now. You want to be the first non-English translation of Rust? This is something where both individuals could help individually, but also having companies supporting this first class and having professional translators help. Either way, if you want to have first-class error messages in the Rust compiler and make sure that the very next language we translate to is one that makes us question a bunch of our grammatical structure assumptions about language, then let's make sure we've got a first-class translation to Chinese.
I might be able to help with that.
Excellent.
In general, translation of any kind of educational resources or that sort of thing, we need to start to communicate better with the non-Western world. And yes, I have horrible English privilege here where I, I get to speak in a language a lot of people speak. I'm not proud of that. I wish I had the time and energy to learn Chinese left in my life. But what you can do is help bridge that. Bless you all for putting up with us. And yes, please do jump in and grab things and translate them and talk to us and help us understand how we can provide you with better stuff.
Yeah, I just want to say it's been a pleasure chatting with people that are interested in Rust and getting involved and have been involved. And yeah, please do not feel like you can't reach out, that you can't make mistakes if you make them, that you can, even if you don't think your English is very good, we all can try, and communication is hard even within languages. So
yeah, this is definitely one of my pet peeves, so I'm glad you said it, is, look, your English is fine. If we can figure out a way to communicate. On the train yesterday, I spent a long time communicating with someone who didn't have a word of English, and we just had great fun. Don't be self-conscious. We aren't judging here. We're really excited to talk to you, so do it.
To put it in another kind of perspective, unless you're talking to one of a very small subset of the Rust community and Rust project group, your English will be way better than our Chinese.
Oh yeah.
So that's all very positive. I guess one challenge is, so something I've really learned from this week is my internet experience on my phone has been very different to my internet experience via Wi-Fi, and there are some challenges there that I now understand a little better than I did a week ago, and so that's always going to be a thing.